Hello everyone. In the last video we saw what equipment you can use in the lab to measure the rate of reaction. In this video we're going to be looking at how we can use the data from that equipment to actually calculate the rate of reaction. And the first calculation we're going to be looking at is how to calculate the mean rate of reaction, or the average rate of reaction. This is the mean speed of the reaction over a certain time period. So how do we calculate the mean rate of reaction? The mean rate of reaction can be calculated by measuring either how quickly the reactants are used up or how quickly the products are made. If you've measured how quickly the reactants are used up, you use the first equation, which is the mean rate of reaction is the amount of reactant used up divided by the time taken. Or alternatively, if you've measured how quickly a product is made, you'd use the second equation, which is the mean rate of reaction is the amount of product made divided by the time taken. So let's have a look how you would actually do this in practice if you're measuring the rate of reaction in a lab. So in this reaction I've got some hydrochloric acid and I'm going to add to it some magnesium. So we're going to measure the volume of gas made in the first 10 seconds and then use that information to work out and calculate the rate of reaction. Okay, so here we go. Magnesium's gone in. Start the stopwatch for 10 seconds. We can see the gas syringe being pushed out by the hydrogen gas being made. And when it gets to 10 seconds, I'll stop the stopwatch, take the bung out. Now I can read the gas syringe at my leisure, and it's showing 20 centimetres cubed of gas. So how do we calculate the mean rate of reaction using the results we've just obtained in the lab? Well, clearly we were measuring the amount of product made, so we need to use the second formula that we've been looking at. So the mean rate of reaction is the amount of product made divided by the time taken. The amount of product made was 20 centimetres cubed when I read it off the gas syringe, and the time taken was 10 seconds. So the mean rate of reaction is 20 divided by 10, which is 2 centimetres cubed per second. Sometimes on your exam, you'll be expected to read the information off a graph and then put it into the equation. So let's have a look at an example of that. So the question could be, calculate the mean rate of reaction for the first 20 seconds, and you'd be provided with a graph to read off. So the first step is, using the graph, find out the total volume of gas produced in the first 20 seconds. So a good hint is to draw horizontal and vertical lines on the graph to help with reading the values. So we can see now, after drawing those lines, that after 20 seconds, 36 centimetres cubed of gas has been produced. We then put these values into the equation using the formula rate of reaction is amount of product made divided by time. So the amount of product formed was 36 centimetres cubed, the time was 20 seconds, and that works out at 1.8 centimetres cubed per second. The units of rate are taken from the equation. So in this case, centimetres cubed is divided by time in seconds. So the units are centimetres cubed per second, or cm cubed slash s. So now that we've looked at how to calculate the mean rate of reaction for a period of time, we're now going to have a look at how to calculate the rate of reaction at a specific point in the reaction. To work out the rate of reaction at a specific point, for example after 4 seconds or after 20 seconds, you need to calculate the gradient of the graph at that point in time. A couple of important points to remember. The steeper the gradient, the faster the reaction is going. So we'd say it's got a higher rate of reaction. the less steep the gradient, the slower the reaction is going. So it would have a lower rate of reaction. And if the graph is level or flat, that means the reaction has finished. So some knowledge that you need to remember from maths is how to calculate a gradient on a graph. So the first thing you do is draw a tangent on the graph at the point that you're interested in. You then make the tangent into a triangle and you calculate the rise, how much the triangle's gone up, divided by the run, how much it's gone along. The unit will be the unit of the top value in the equation slash the unit of the bottom value. Let's have a look at some examples. So calculate the gradient at 20 seconds. So the first thing we've done is drawn a tangent at 20 seconds and turned it into a triangle on the graph. So there's the tangent in red. Now the rise in green is how much the triangle is going up on the side. And that is 20 centimeters cubed because it goes up from 28 up to 48. The run, which is shown in purple, is 34 take away 10, so it's gone along 24 seconds. So to work out the gradient is the rise divided by the run, which in this case is 20 divided by 24, which is 0.83 centimeters cubed slash seconds. And the units are taken from the y and the x-axis of the graph. The volume of gas is in cm cubed and the time is in seconds, so the units for the gradient is cm cubed per second. Let's have a look at another example. In this question, you're asked to calculate the rate of reaction at 40 seconds. And the graph below shows how much hydrogen was given off during the reaction between magnesium ribbon and hydrochloric acid. So to answer this question, first of all, we need to notice that the scales are different on each axis. The time goes along the bottom 4 seconds at a time for each small square, whereas the volume goes up the side 2 centimeters cubed per small square. So we need to be aware of that when reading off the graph. Now, once again, the first thing we do is in blue, draw a tangent above 40 seconds, and then we turn that into a triangle. And we can see in green that the rise is 4 centimeters cubed. And the purple shows the run, it's going along 16 seconds. So in this case, the gradient, which tells us the rate of reaction at 40 seconds, is going to be 4 divided by 16, which is 0.25 centimeters cubed per second. The answers you get might be slightly different depending on how you drew the tangent to start with. That's okay. Often in the exam, the examiners will give you a little bit of wiggle room depending how you drew that initial line. So in this video, we've seen how you can calculate the mean rate of reaction using the formula. And we've also seen how you can calculate the rate of reaction at a certain point in the reaction, for example, after 20 seconds, and we do that by calculating the gradient from the graph by working out the rise divided by the run. In the next video, we're going to have a look at how the rate of reaction is altered in terms of what's going on with the particles, and we'll look at something called collision theory. If you found the video useful, remember to click subscribe, tell your friends about it, and you can also head over to my website, which is www.revisedchemistrywithmrb.co.uk. Thank you for watching.